In the last example, we see that if I have a bunch of vectors, they are going to be linearly independent precisely when the rank of this matrix A here is equal to n, which is the number of vectors. This is kind of important, so let me actually just go ahead and copy and paste this thing here. Now, we also see from one of the earlier examples, this was back in example 1.8, that the rank of the matrix has to be less than or equal to m. So one thing that I can conclude from these two facts is that, well, if the value of n is greater than m, if n is greater than m, what that means is n is going to be greater than the rank of the matrix for sure. And that's because, well, the rank of the matrix cannot exceed m. So if n is greater than m, then n is going to be greater than the rank of the matrix for sure. So what that means is the rank of the matrix cannot equal to n. So the vectors that I have, they are not going to be linearly independent. So they are not linearly independent. Not linearly independent. This is actually the same as saying that they are linearly dependent though. Okay, so in a nutshell, what this kind of means is if n is greater than m, that means I just have too many vectors. If I have too many vectors, then that means some of the vectors are gonna be a linear combination of some others. For example, if I look at the first two examples here, these guys are gonna be in R squared, so my m is gonna be 2 and my n is gonna be 3. Notice that n is greater than m here, so I can conclude right away that these guys, they are not linearly independent. So these guys, they are not linearly independent. And that's because the value of n is greater than m. I have too many vectors than my coordinate can afford. And we can actually have seen the first example. This was in example 4.2. The last guy, this is basically 2 times the first guy plus 3 times the second guy. And for the second one, well, all of these, they are just a multiple of the first one. And now for the bottom two, all these vectors here, they are in R cubed, so my m is 3 now. But I have 4 vectors, so once again, I have too many vectors. So these guys, I can conclude right away without doing any computation that they are not linearly independent. If I were to form a matrix out of these vectors, the rank of the matrix is going to be at most 3, so there is no way that the rank of my matrix is going to equal to n. And because the rank of my matrix is not equal to n, I can conclude then that they are not linearly independent.